In Module 3, Lesson 24, we're going to explore the volume of a right prism in more detail. The picture should remind you of Lesson 22, in which we had the jewelry box problem. Measuring a container's capacity. Now, the box in the shape of a right rectangular prism has a length of 12, a width of 6, and a height of 8. The base and the walls of the container are 1/4 inch thick, and its top is open. We want to know what the capacity of the right rectangular prism is this time. And remember, the last time we were looking for surface area. So this will be somewhat different. The capacity is equal to the volume of water needed to fill the prism to the top. Now, we're not going to fill this prism with water, nor is this any different of a calculation than what we would have done. So what we're looking at then is a rectangular prism, and what we need to calculate is what the interior dimensions are, because we want to know what will fit inside. So first of all, let's determine its length. There's 1/4 inch here, 1/4 inch there. So we need to subtract 1/2 of an inch from 12, and that means that its length will be 11 1/2 inches. Then its width started with 6, and again we have 1/4 inch here and 1/4 inch here, so we'll subtract 1/2 inch from 6 and get 5 1/2 inches. And then finally the height, keeping in mind that the bottom has 1/4 of an inch thick, but it goes straight up to the top, so there's not another 1/4 inch taken off of the top. So we're going to subtract 1/4 of an inch from 8, and that will give us 7 3/4 inches for our height. Now, once we have those three dimensions, to find the area, all we're going to do is find the volume, all we're going to do is find the area of the base. So that's going to be our first two measurements multiplied together, and then multiply it times the height. 11 1/2 times 5 1/2 times 7 3/4. It's all multiplication, so we can do it all at one time. And that equals 490 3/16 cubic inches. Example 2 talks about actually measuring liquid in a container in 3 dimensions. The glass container is in the form of a right rectangular prism. The container is 10 centimeters long, 8 centimeters wide, and 30 centimeters high. The top of the container is open, and the base and walls of the container are 3 millimeters or 3/10 of a centimeter thick. The water in the container is 6 centimeters from the top of the container. We want to know what the volume of the water in the container is. Just like we did in example 1, what we want to do is determine what the actual dimensions of the interior of this particular container are. So we'll start off with our length. It's 10 centimeters on the outside, and they told us that the walls of the container are 3/10 of a centimeter thick, and we really need them to be in the same units. Please don't try to mix millimeters and centimeters. They have to be in the same units. So if each side is 3/10 of a centimeter thick, that means altogether they are 6/10 of a centimeter thick. And so we subtract that amount from 10 centimeters and we get 9.4 centimeters for our length. Then, looking at our width, it was 8. And again, there are 2 walls that will be a total of 6/10 of a centimeter thick. So we'll subtract that from 8, and that will give us 7.4 centimeters for our width. And then taking a look at the side, this will get a little more complicated. Remember, the top is open. The bottom is 3/10 of a centimeter thick. So what we're really doing is 30 minus 3/10 of a centimeter. But then keep in mind as well that the water stops at 6 centimeters below the top of the container. So we'll have to subtract those 6 centimeters as well. And so our total height is going to be 23 7/10 centimeters. Once we have the measurements, all we really need to do then is multiply 9.4 times 7.4, that's the area of the base, times 23.7, which is our height, and we find our volume to be 1,648 and 572 thousandths cubic centimeters. So next in example 3, they're telling us that 7 2/10 liters of water are poured into a container in the shape of a right rectangular prism. The inside of the container is 50 centimeters long, 20 centimeters wide, and 25 centimeters tall. We want to know how far from the top of the container is the surface of the water, keeping in mind that 1 liter is equal to 1,000 cubic centimeters, because obviously we're going to have a conversion problem. Now what I notice right away is that they've told us the measurements of the inside of the container, which is important because now at least we don't have to calculate the dimensions. The inside of the container is 50 by 20 by 25 total. We don't actually know how tall the water is, and that's what we're trying to determine. How tall is the water, and then how far below the top of the container is that water. So first of all, we'll need to calculate the capacity of the entire container. And the capacity of the entire container would be 20 times 50 times 25. No, scratch that. Let's not find out the capacity of the whole thing. The area of our base is 1,000. Okay, that's good. Now, they are telling us, this is centimeters, and that's actually squared there. They're telling us that 7 2/10 liters of water are poured into the container. So they're telling us the volume that is in the container, keeping in mind that 1 liter is 1,000 cubic centimeters. So what we would do then is convert 7 2/10 liters by multiplying 7 2/10 times 1,000, and that will actually give us 7,200 cubic centimeters. And that is going to be equal to, remember this is our volume, this is equal to 20 times 50 times our unknown height, we'll call that h, in which case we really have 7,200 is equal to 1,000 times h, and we'll divide and find 7.2 centimeters is the height of our water. Then in order to find out how far below the surface it is, we simply need to subtract 7.2 from 25. And that will give us 17 and 8/10 centimeters from the top. In example 4, we don't have a picture. They tell us that a fuel tank is the shape of a right rectangular prism, and it has 27 liters of fuel in it. It's determined that the tank is 3/4 full. The inside dimensions of the base of the tank, inside dimensions, are 90 by 50 centimeters. We want to know how deep is the fuel in the tank. In other words, how far from the top is the fuel in the tank, and how deep is the tank altogether. So we're going to do essentially the same thing. We have 27 liters of fuel, and that translates then to 27,000 cubic centimeters. There's our volume. And our volume is going to be 90 by 50 times the height. So 90 times 50 times the height will equal 27,000. And in solving, then we divide 27,000 by 4,500. And find that our height is 6 centimeters. This is the height of the fuel. How deep is the fuel in the tank? It is 6 centimeters. Now, how deep is the tank? We know that the tank is 3/4 full. So then we know that 6 is equal to 3/4 of the height. And we solve that by dividing by 3/4. If you divide by 3/4, it's the same as multiplying by 4/3. That gives us 24/3, which is 8 centimeters. So the depth of the fuel tank is 8 centimeters.